So why isn't the team doing that? I mean, okay, so the problem is if you're trying to solve a problem and it requires various types of, let's say, some tech, some design and stuff like that. I don't care who the proxy is that's telling that group of people what's important. They can't possibly have the background of the diverse people on the team. They don't have a tech background, a design background, a market background. In all of the product teams I ever worked on, marketing and design and technology were equal status on the team. There was, yes, a leader, but the leader was more like a CEO of a startup business than a product person, because product was one of the co-equal people on the team. And yes, you had to have various specialists in various areas that worked to figure out what to do, but they worked in conjunction so that, in my experience, a really good product has trade-offs. And the trade-offs oftentimes are between, say, technology and quality, or market and need to get to market fast and need to slow down to get the right technology in there. There are all these trade-offs. And the trade-offs are best made when the people who understand in detail the kinds of issues that happen if you make the trade-off can have arguments with each other, discussions, disagreements, so that they can come to some sort of an agreement. I call them fair fights. And these fights have to be fair, okay? That means if you have the one person who happens to represent, let's just say, product, as the senior person who gets to make the decisions, forget fair fights. If you have both the technology and a designer lead, and then maybe a market person, and they have equal status and they can argue with each other without anybody saying, oh, I'm right because I'm in charge, then you get much better trade-offs. So the idea that we have a single product person telling the team what to do completely limits our ability for that team to be creative, because they do not have a way to discuss, oh, but you have forgotten this issue with technology. You don't quite understand that the user experience isn't just going to be great if we do that. We need to be constrained by this time frame, and if that's so, we need to do this different thing. And you need to be able to have those discussions, which means you can't have a single person telling the team what the rules are, because then the team doesn't get to think anymore. And you don't get that great background of all of these different people having differences of opinions that they figure out how to resolve, because that's where your really good products go.
If you are looking for a much more in-depth discussion, look at the work of Marty Kagan, Silicon Valley Product Group. That's his whole world, is how to apply these kinds of ideas to product development.
Oh, I agree. You can't have a single team working on one thing that's not completely independent. But I think that you can, let's just take an example, okay? Let's just look at AWS, for example. I'm going to give you two examples. One is AWS. AWS has independent teams that are approximately 8 or 10 people, led by a person who acts more or less like a mini CEO and has all of the different kinds of people on it. And they have a specific role in a chain of things that happen. And yes, it takes a few teams to do a service, but if you look at AWS, they're adding new services every year, about 300, which means like one a day. And they've been doing this for 12 years. How is it that they're completely able to have extraordinarily complex products, and yet they have very independent teams? Because their architecture, they kind of invented an architecture that supports it. That's the cloud architecture. And it came from the fact that that was the vision of Jeff Bezos to begin with, that if you don't have independent agents making independent decisions as groups, you are not going to get the best decisions and you can't scale. I propose that anything that really needs to scale can't possibly scale in a manner of tight coupling of lots of dependencies. That is the thing that keeps you from being able to scale. Now, you might have a product, let's just take a rocket, okay? Airplane, car, that's a single product. But the ones that are really good at, whether it's SpaceX or Tesla or Toyota, but let's just take SpaceX because it's a really good example. So they have a rocket and it's going to shoot up, and their underlying goal is, we know if we want to put stuff in space, we have to be able to do it a lot cheaper. So they started out with the idea of, we can't keep dumping all of this junk into space or into the ocean. We have to be able to be reclaimed and reuse all of the stuff that we send up into space. Now, nobody knew how to do that. And they did some of the best engineering I've ever seen over a period of about 5 years to create rockets that land and are reusable many times. And they did it by having, this is what you almost always see in a complex system like that. You form your teams around components. So you think of systems engineering, which is, what is the architecture of a rocket? Okay, it has a payload, it has a first stage, it has second stage, it has Merlin engines, it has legs that are going to go up. You have a single chief engineer, and the chief engineer says, in 3 months, we're going to do a test shoot. Okay, we're going to do a test blast off, and here's the objectives. And then for each subcomponent, you have a chief engineer who works with the other chief engineers to say, how are we going to do this? How are we going to interact with each other? And on each component, you might have 3 or 4 different teams dealing with subcomponents inside of the component. But the job of the team is twofold. One, when that shoot happens in 3 months, their piece has to operate correctly, because otherwise, and if it doesn't, they had better have, a lot of monitoring so that they can tell what went wrong so it never goes wrong again. And they have to know what the role of their piece is in the whole system. Nobody tells them, they have to know. They can depend on the chief engineer of their area. Typically they can go to, let's just say I'm a landing leg engineer and I need to lock my landing leg into the drone ship, and there's going to be a locking mechanism. Okay, I got to work with a locking mechanism team. We got to talk to each other, because as a locking mechanism team, I got to know how the leg works. As a leg mechanism team, I got to know how the locking mechanism works. And we get together so that we know for this next test, how are we going to try things? What are we going to do? And we make those decisions, because when that blast off comes, it happens. And we have to be prepared. And our job, our responsibility is really clear. Our piece has to work, and we have to know what its job is and the overall objective, and we have to make sure it does that job. And you can have a lot of teams that are relatively small if you have that construct of teams are responsible for their piece and for knowing the role of their piece in the whole system and how it interacts with other pieces and making sure it does that role. And anything that's large and that works really rapidly and well tends to have that architecture. Either it's completely disjoint, as AWS tends to be, or it's a systems engineering component-based kind of structure. Those are the 2 product structures that I've seen that can work really well. And you see massive kinds of products based on those architectures. Those architectures are absolutely possible for products. It's a different mental model, I agree, but it works better than the mental models that have deep dependencies.
I suggest that we're using the term team in the wrong way. In my mind, a team is a group of people working together to achieve a common goal. Now, that group is not limited to the classic 7 to 10 individuals. That team might be 100, but they all measure their success primarily by, did the rocket take off? Did the rocket achieve orbit? Did the components land successfully? And so forth. Now, as problems get harder and more complex, you need to break up the work, as Mary described, into sub-teams, which have to do their part and understand how they collaborate effectively with neighboring parts. But their primary success metric is, did the overall effort achieve its current goal? Their secondary success is, did my contribution do its part in conjunction with those parts that I depend on? And that kind of scaling actually occurs at Amazon. It actually occurs at SpaceX. It actually occurs with the Falcon team. It occurs with the Starship team. It occurs with the team that is doing the Starlink satellite internet service. It occurs always. Scaling is within the context of a shared success metric.
So yes, back when I was in college, I think it was about that time, there was a really interesting book published called The Structure of Scientific Revolutions by
Thomas Kuhn.
And he talked about how scientific, that's actually where the word paradigm came from. How, and it's the same as mental model or paradigm. And he talks about how they change in the scientific community. And he basically says that people get to a certain point where their success depends upon being good in the current mental model. And it's almost impossible for them to change. So pretty much you almost have to wait for a whole generation of scientists to retire before a new mental model can take over. And the new mental model comes from people operating outside of the existing mental model, trying something and trying it several times and turns out to be better. But the ones who are used to and successful in the old mental model almost can't accept that. So they kind of have to get out of the way. And in science, it's retire. In industry, it's a little bit different because there's competition. And when competition starts wiping you out, then the question is, does the leadership of that company, under the intense problems generated by competition or by a very rapid change like a pandemic, do they still want to cling to their old mental model, or are they willing to change? And I want to give you a mental model that you will be familiar with, and that is up until the late 90s, every single company that was formed had an IT department. That was their department that did their computing, and that computing tended to be focused on process automation inside the company. Starting with the internet becoming widespread in the mid to late 90s and after, most of the companies that were founded to do technology, to do software, most all the Silicon Valley companies had no IT department. Amazon, interestingly enough, was an exception, but they had no IT department. They had no concept of an IT department because they thought of engineering as engineering. And so Google has always had engineers. It doesn't have IT department. It does have people who maintain their data centers, but right now that's a pretty interesting job. So if you think about that and you think about a mental model, when we were trying to do just in time in our manufacturing plant, the mental model was driven by the accounting system, which basically said that assets are good. And our mental model said you want to not have assets. If you're working in an area that says backlogs are good, it's exactly the same thing. And my mental model says backlogs are just, they gum up the works and they get in the way. So sometimes if you're dealing with people who've been successful with a current, an existing mental model, either they can't accept it or competition is going to force them to accept it. And I haven't seen a really good way of forcing people who have been successful with the mental model to change, because I have actually talked to the senior staff of very, very big bank IT departments, and they can't buy the fact that if my mental model is true, their job isn't necessary. I mean, that's impossible for them to accept. And so there comes a time when they have to retire or they have to get wiped out by a competitive environment that doesn't tolerate the slowness in order for it to work. So it's not easy to change mental models. But if you have mental models that you think are right and can test them, you can be the young scientist that comes up and shows that this mental model is better, or you can look for a place where that mental model is important, or you can wait until something serious happens and you can say, given this pandemic, we can do this much faster this way because we've got some emergency or some competition. So it's not easy to change mental models. That's what maneuverability is all about. And maneuverability is become way more important these days than it was even 6, 7, 8 months ago. And maneuverability really, really means ability to rethink mental models. And it's hard. It's really hard. You can rethink yours. It's really, really hard to get other folks that, if their success depends on the mental model that they're clinging to, they can't give it up.
Our first book was called Lean Software Development and Agile Toolkit. And this conversation brings to my mind that the key word there is the last one, toolkit. Your mental model is the toolkit that you use to think with and make decisions with and decide what aspects of the environment that you exist in are going to be useful for making decisions, making choices, taking actions. That's a toolkit. We all have toolkits. If you're a developer, you have software toolkits, process toolkits, all kinds of toolkits. If you are a leader in an organization, you also have toolkits. Now, in the software world, we're quite used to adopting new tools every few months. Certainly every year, we have a new set of tools that we do our thinking with, do our creation with.
Like Zoom.
Yeah, but
for example,
the question is really, how do you enable your organization's leadership to view the way it thinks, not as a obvious truth, but as a toolkit, which has components that you can change as the opportunities express themselves, as experience shows that this tool works better than that tool, or this combination of tools is more effective. So the concept of a mental model is very fundamental. We all have them. In some sense, it's all we have. The real question is realize that how we decide, how we make decisions is not intrinsically right or wrong, but it's right or wrong in the context of a certain set of criteria that our mental models tell us is worth paying attention to, and that the dependencies among things we pay attention to, if we make this choice or that choice, will lead to predictions of outcomes that we're trying to achieve.
Yeah,
does that make sense?
I have this theory that in my world, because I've been in software development or software engineering for decades, anything that's 10 years old is obsolete, and anything that's 20 years old is hopelessly out of date. So do the math. The question is, how short is the buffer? It needs to be as short as possible. And what is the purpose of the buffer? It's to absorb variation. If you don't need to have it because your input flow is very steady, let's take our blog writer. She actually doesn't need to be out more than 2 weeks on blogs because she has a steady set of requests for blogs. The shorter you make it, the more current every request is, and the more relevant it is, the less likely it is to have changed from the time it got in there until the time it comes out. So there's way many reasons to keep the buffer as short as possible, but you don't want to run out of stuff. So if you have any kind of seasonal demand, or end of the month, beginning of the month, or whatever, and you're going to drain your buffer too fast, then you want to have it long enough so that you probably will still have something in it. But you want it short. I remember in here 10, 15 years ago, you would call up a doctor to get an appointment. I know our healthcare system is always different than any others, but still. And you were lucky to get an appointment somewhere between 30 and 60 days, unless it was an emergency. And then all of these doctors' offices got some consultants that says, You know what? You don't need a month or 6 weeks of people waiting for appointments. What if you sort of worked off your appointment queue, like working a little bit on the weekends, and tried to drive it down to about a half a week so that anybody who calls can get an appointment within 2 days? And the doctors were nervous, right? But they said, okay, let's try it. So they would drive their queue down there to 2 weeks, and then to 1 week, and then to 3 days, and then to close to the next day. And they discovered that there was no difference in the amount of demand that they had, no difference in the sickness of patients, except for the fact that they were being seen much earlier. So if they were going to get sicker, no difference in the types of stuff that happened. That 6-week wait made no difference at all. It just made things take time. And backlogs have a tendency to make no difference at all. Lines don't add anything. So you want that buffer to be as short as possible, and you want to keep driving it down until it's as short as possible in your context. Different contexts are going to have different things, different ways of thinking about that, but it needs to be short, because you don't need to prioritize. You need to be able to have a cutoff line saying anything that's below this, we don't want to put in our queue, because guess what? That's the kind of stuff that just clogs it up. When you have a really short queue and people are starting to come in with demand and they realize that they're going to get an answer within a half a day as to whether or not you can handle it, and you say, oh yeah, that's good, and you're going to have it in 2 weeks, or, oh, you know, I absolutely don't have the capacity for that. If those are your two answers, your people creating demand really rapidly learn your cutoff line, and you stop getting superfluous demand that you're going to have to handle and prioritize and stuff like that. So the faster you can flow stuff through your system, the more pertinent stuff is, the faster customers get stuff, the fresher the stuff is that you're working on, instead of having to go look back at what changed in the month since it got in your queue. There's just so many good things about making it really, really short. There's no reason not to in most domains, but not all domains.
One style of applying lean thinking to software is called Kanban. You're probably familiar with it. The central tenet of Kanban is limit work in process. Now, the contention that I would make is that when you put something in a backlog, it is in progress. Why? Because if it's in a backlog, it starts absorbing energy. It starts absorbing prioritization. It starts absorbing some degree of understanding of,
and it's created expectations.
What that item is, some amount of, I guess, expectation management, as Mary says. So it's really in progress as soon as you put it in your backlog. And that absorbs a lot of energy from everybody involved, from the people who are making sure that you still are going to do it, your customers, the requesters, the audience for your product, from the people who are trying to organize the group of people developing the product, from the developers themselves. Everybody has their energy at least partially focused, distracting from what they're trying to do right now by having it in the backlog. The shorter that is, the more relevant any of that energy will be to actually achieving the part, rather than trying to say, do I have to worry about achieving this yet?